Hello, I'm back, and thank you so much for tuning in. This is Jane with the group I started on last night. We call ourselves the Second Winders, people that are coming on, and I see the group is steadily growing here, and I'm so glad that you're able to benefit from my blog here. Basically, what we're going to do is we're going to go over the squaring. This is going to be part 3 to a series of math dealing with parabolic equations, also dealing with the quadratic function formula and square root and the standard form, and also how to deal with polynomials. Just know that we'll go into depth with that eventually. But tonight we're going to focus on squaring the parabolic equation here. There's several names for it. The official name for it is the quadratic equation. This is the standard form. The parabolic equation is because of the x carries a nth degree of 2 to the second power, if you will. Just to let you know that it touches the x-axis and then goes back up or down or whatnot, depending on the sign. What I mean by that, depending on if it's a plus or minus, it will tell you which direction, but we'll get to that another day. But right now we're going to focus on how to even get the point. How do we even get to x? How we make x 0? How we use x intercept and get it to where we can use it in a sense of 0 at the 0 point, being on that specific point, reflecting a number. In other words, getting a point on a graph on the exact x-axis is where I'm going. So we'll get started. I'm just kind of hanging out on the sofa here. I left my table. I have a dinette dash slash work area for school slash retreat, and sometimes I go in there and I get on the internet on my computer and whatnot and do different things, sometimes study and things of that nature. Sometimes I do it on the sofa here in my living room. So right now that's where I am, in the living room. So I'm holding everything up. I rewrote everything down. The reason why I did that is because it's kind of obnoxious to hear my nonsense sometimes and then turn around, have to see my hand all in your way when you're trying to see what it is that I'm saying. So I'd rather already have it wrote down and just walk you through it. So like I said, we'll get started here. What we're doing now is we're honing in on this parabolic equation here, and just know that we'll have later times where this actually has a number in front, but right now we're going to do the simplest form. Just know that basically what we're going to do today is get it into a trinomial of a perfect square, and then bring that square trinomial into a form of two binomials so we can get 2 points on the x-axis. So that's where the 2 comes in. It's 2 points on the x-axis in respect for the equation here. So we rewrote everything, and what we're going to do is now that we've rewritten this equation, we're going to bring it down, and what you do is you just take that and skip a line and bring it down. These two right here, you bring this down, the first coefficient, and then the second term coefficient, you bring that down together with this. You leave a little space here because what you're going to do is you're going to isolate the constant. So it's A, B, C, like we talked about in the previous video. If you had not seen that video, please go and view it and then come back. And then once you've done that, you want to with respect to whatever signs here, do the opposite. So in this case, we're going to add it onto both sides and turn our 0 into a 40. And then also keep a space here, because this is 0 now. We have a space now that's available for a third term to make it a perfect square trinomial. And how we do that is we take that middle term and divide it by 2. Once we've divided that middle term by 2, we then square the answer, multiply by itself, if you will, to get the perfect square trinomial. So we're going to take the middle coefficient. That middle coefficient, we're going to divide it by 2. Sorry, it looks like a radicand, so used to writing radicand, but this is just actual division, just simple division. Take that 2, divide it into 6 equals 3, equals 3 squared equals 9. So basically what we did was we took that answer and squared it. 3 times 3 is 9, and we brought it back over here to the equation, and we placed it here. So that's the spot for here. So now we have what we call a perfect square trinomial for those that are doing a refresher, or those that are just now learning how to do this type of math. Just know that that's how you come up to getting from standard form to a perfect square trinomial. You could do this anytime this number here is usually even, or you could see that you can make a square root formula out of it by doing this way. This doesn't have to square into a square root, but you want it to be where at the end of the day it's where when you finally figure up that third term, and you can make that term times it by itself by making this third square term, or what we call a trinomial term, and getting it to get back under the radicand and also square it. So you take 2 of these. In that previous video I did this, we're just doing this in reverse from the previous video. So if you had not seen my previous video on the concept of how to get this into this, you won't get what I'm saying. So just know that we're referring back over the ones that have watched the previous video. We're referring back over the previous video, but we're doing it in reverse. This time we're taking it from the trinomial to the perfect monomial. So, and we're going to square that. So that means that it can't be factored anymore. It's all totally factored, but if we times it by itself, it will add back to this. So that's where we got that. Okay, so now we're going to do the same to this side. We're going to bring it under the radicand, because remember, we're still working under the quadratic formula, even though we don't use the sign and all the way it's set up and all that stuff. So just know that it's a constant. So you'll see that this is a perfect square. So that perfect square does come up to 7. So 7 times 7 is 49. This radicand that we place back over here and that 2 cancel each other out. So you release all that from under, release all of this from over the this term here, and you can go ahead and release all of that, bring that term out of there, because that releases that. So now it's free. The fact that you've squared this, whenever you square something that's under the radicand, you bring it out of there and bring it out, and it's free. You don't ever put it back. You always know that once it's squared, it comes out of there, and then it's free to be on its own and in its own self. So now we've gotten that. We're going to rewrite it. Once you've rewritten it, you're just going to, in respect of the plus minus sign, you know how when you have your x equals the negative b plus or minus, that plus or minus is the part that we're on now as far as the quadratic formula. So remember, that's the last formula that we went over on the last video. So please revisit that video if you're not familiar with what I'm saying. So just know that you want to research the quadratic formula to understand where I'm coming from. So we just brought that down, because we know that that's coming down with it in respect for the quadratic formula. And this is going to give you 2 answers, okay? So this doesn't go away. This stays with it until you separate it. So we're going to separate it now. So all I'm saying is that now that you've gotten your perfect square released, and then you can go ahead and take that constant here and add it or subtract to both sides in respect for this sign here, and then take one of these and put it in front of this number here. So and we're going to rewrite that over here. So we're going to take these 2 numbers and we're going to say x equals minus the 3 on both sides, so that's 0, and so that turns into x by itself, and then minus the 3 plus the 7. So x equals minus 3 plus 7, and then we'll do the same over here. X equals minus 3 minus 7, so we got a 10 over here because the minus and a minus is a minus when you add them together, and a plus and a minus is whichever is bigger. In this case it would be plus, and then you just check it. You go over here, you check your answer by replacing it. Wherever you see an X, you replace it. So you use the first one, that's the negative 10 that we've gotten. So you've gone in there and you've done the squaring of the 10, and then also the squaring, the multiplication of the 6 and 10, and you've gotten the 2 figures here. Remember your sign, that when you times negative times a negative, it turns into a positive. So you don't need to bring that down because it's 2 negatives canceling each other out doing multiplication. So that is equals to 40. So you see that worked, and the same as here, as you can see. So all you do is you do your PEMDAS, and we'll go over PEMDAS later, but you just follow your PEMDAS in order and bring everything down. Square that's 16, bring it down. And this is the way you take care of the simpler form, that's factoring. Factoring, all you're doing is dividing this into 2 factors, so that way you can come up with the same answer. We'll go over that another time, but basically whatever 2 numbers times make this number, which happens to be 10 and 4, and add up to be this number, then you can use it. So in this case, the plus 10 and the negative 4 adds up to 6, and also multiply to equal 40. So that's how we got that, and you'll see that we got the same answer. So I hope this was of a help on how to handle the set notation, or the set, not the set notation, but the set solution set. The solution set of x is 4 and negative 10. And you enjoy your day. It was a joy and a pleasure having you on and looking at the video. We'll be back on tomorrow and learning how our United States got together and formed the first bank. So tomorrow we'll be going over how the United States created its first bank, where our dollar bill got started, and all that good stuff. So that's the history lesson for tomorrow. Hope you tune in. Have a blessed evening. Please like or subscribe if you like. If not, it's okay. Just come on and enjoy it. And I hope to have you again. This is the signing off of the quadratic formula. And also we'll be going over the history lesson of the beginning of our banking system here in the United States. I hope you find it interesting. Signing off with the second winders, and you have a blessed evening.